This is geotrig lesson 15.
Day one.
No, this is going to be day one and it, because we're going to finish this all today. So, we've talked about this before. I think back when we first introduced proofs, I kind of gave a rundown of what axioms are and postulates. And so I got some definitions here for that. And then I also talked about how we had those 10 postulates that everything that you guys would know for math is based off of. So that we're going to assume to be true, and if you take any of them away, then all the math that we have been building and using disappears. It falls apart. So, first up is the assumptions. Axiom is an assumption that is true in all areas of math, where a postulate is just kind of a particular branch of math. So, some of them, they will kind of cross a little bit into a couple that we know, and others are just more for your algebra or more for your geometry. Okay? So, not really all that important for what we're doing today. I think the next 10, we only got 4 on the first page there, but the next 10 are a little bit more important. These are called Euclid's postulates. All the math that we know are based off of these, at least geometry or geometrically. 2 points determine a straight line, a unique straight line. So if you take your fingers and make 2 points in the air, there's only one way to connect those, right? Through those 2 points. 2, a straight line will extend indefinitely far in either direction. That goes in both directions. Yeah, we've known this for a long time. 3, a circle may be drawn with any given center and any given radius. So as soon as you put a point in space and give you a length, you can spin that length around the center, forming a circle. Yeah, we've talked about that before, I think, right? And then all right angles are equal. And we've talked about this before as well when I said, hey, angle A and angle B are right angles. We turned around and said angle A and angle B are congruent. Why? Definition of a right angle, they are all equal. Right angles are equal. Next up is postulate number 5. This one, when you read it, it's a little complicated. Once you see that I put a diagram here for it, it makes it a little bit more. It makes it a little more not interesting, but plain language. Maybe not plain language. Easier to digest. It says, given a line N and a point P not on that line, there exists in the same plane as P and N, through P one and only one line M, which does not meet the given line N. Got it?
No.
Okay. What does it mean? A point P and a line N. Yeah?
Yeah.
That are not on, point P is not on the line. So as you can see on the left here, you got that situation. What it says, that in the same plane, remember your board here, or your paper is a plane, right? So it doesn't matter if it's straight up and down, laying on the desk, or on the different wall. Those are different planes. So as long as they're on the same plane, there exists one and only one line M that would go through P and not touch this bottom one. AK would have to be parallel. So there's basically says there exists one other line through P that would be parallel to the one that was original. Does that kind of make sense?
No.
If you have a line and another point somewhere else, there will exist another line that will be parallel to the original through that point. Think about it. Guys, things equal to the same thing are equal to each other. Well, that kind of makes sense. Isn't that kind of more like the transitive property, I think it is? If A is equal to B and B is equal to C, then A is equal to C. Okay? You've seen that before many times. 7. If equals be added to equals, the sums are equal. Well, if you guys all have the same amount of money I do, and someone gives us all $5, guess what? They still have the same amount of money. The next one, if equals be subtracted from equals, the remainders are equal. So now if someone takes $5 from everybody, everybody still has the same amount of money. Right? Because we all started the same. Figures which can be made to coincide are equal. If you can take one square and take another square and they match up perfectly, then they are the same. They're equal. And the last one, the whole is greater than any part. Right? That makes sense, as in your whole entire desk is greater than just the tabletop or just the seat. That's only part of the whole thing. Okay? Didn't say anything about is it still work or can you still use it. It's just saying that when it's all put together, the whole thing is greater than just the parts individually. So as you guys are finishing those up, what we're going to do then is we're going to still talk about some of the same things we did last time, reflexive properties, alternate interiors, alternate exterior, straight angles are 180 degrees, vertical angles are congruent, those things, and possibly add a couple more things here. Some of these other ones could show up in some of our proofs. So, these ones, you guys remember this? Triangle congruency? Yes, unfortunately. There were 5 of them. 1, 2, 3, 4, 5. SAS stood for?
Side, angle, side.
Side, angle, side. You should have all of this, yes. SSS is?
Side, side, signature.
Side. Side, side, side. AAS. Angle. Angle. Side. I'm not going to write the other part in parentheses, but why is angle side the same thing as angle side?
Because if you think about it, 3 is equal to 2 because if you add 1s, it's equal to AAS. Hold on.
I'm not going to go with that definition or that help. He started off, I think, going in the right direction, and then he just carried it to a different way.
Oh, because the triangle has 3 angles and a side.
3 angles, 3 sides.
Yeah.
Okay.
And if you name 2 of them, then the third one has to be equal.
Right. Guys, remember, if you know 2 angles in a triangle, you also know all 3, not sides. 2 angles are the same in a triangles, then all 3 are the same. So, essentially, if you know angle side, you could also then know angle side. One of our problems, we're going to talk about that, kind of like why I would use one over the other, and when I would use the other. So, or the other one. HL? Hypotenuse. Leg. Hypotenuse leg. And? I forgot to talk about hypotenuse leg there. When can that one only be used? In a right triangle. 90-degree triangle. Now, notice on this 5 lists, all of these were there to help us state one triangle is congruent to another. Which one is not up there? Angle side side. Angle side side is not enough to prove 2 triangles are congruent. There is no donkey postulate. So do not use that one. And then we got the fun one on the bottom there. CPCTC.
Congruent parts of a congruent triangle are congruent, right?
Corresponding
Parts.
parts
Congruent structure.
of congruent
Are congruent.
triangles are congruent. Corresponding parts of congruent triangles are congruent. Remember, you only can use that when you have already stated the triangles are congruent.
Oh.
Okay? So, we got some proofs. These should look very familiar because we may have actually put these in our notes once before. Because again, I said I covered this already. I'm just starting off with nice, fun things here. Remember, we're going to use two column proofs, statements and reasons. So everybody in here should be able to start one of these. Statement and a reason. We got a statement and a reason. The first thing that goes for a statement is the given stuff. BD is angle bisector of B, and AB is congruent to CB. Reason? It was given to me. I'll switch colors. Now, obviously, if I'm given some information, I probably should go to my diagram and put it on there. We'll start with the second half of that. AB, segment AB, is congruent to CB. AB is here, CB is over here. So AB, BC, they are the same. I put my tick marks on there. That makes it a heck of a lot easier, doesn't it? I can actually understand. Oh, I know those are the same. Can I right now go on to that graph or that chart and put some kind of angles are the same? Because it says it's an angle bisector. Wait, what's an angle bisector again? Yeah, it takes an angle, it cuts it in half. But I can't state that they're congruent yet until I state them. What angles are the same? Hayden?
B.
What of B? Because you can't, there's more than one angle.
AB.
Angle
ABD
A, B, D
is congruent to
is congruent to C, B, D. Reason though. Definition,
bisector.
angle bisector. Definition of angle bisector. What's 3 then? Does everybody get that? I had to state that, so now I can go and put it on my chart. And on my chart, those two are the same now, aren't they? So, what's another one? Monica? Hand was up. It's recording. Hello. Reflexive. What is reflexive? BD. BD is congruent to
BD.
BD. Reason? Reflexive property. Remember, reflexive property means something is congruent to itself. Okay, by chance, could I also state that AB is congruent to AB? Couldn't I state that this is congruent to itself? Yeah, I can say anything is congruent to itself, but I only want to state the things that are going to be conducive to the proof. So I go up here. This makes sense that I would say that those are congruent, right? Because they're shared in both of the triangles. Do I have enough information now to state that they are congruent? So what are my triangles? 4. Triangle. A, B, D is congruent to triangle C, B, D. What's the reason? Side, angle, sine. Are we done? Are we done with the proof? No, because the proof is asking us to do what? Show AD is congruent to CD. Do we have enough information to now state that? And the reason? What's the reason? C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So this one. This one is starting to use some of those ideas. I think possibly, well, no, because this has parallel lines. So I guess we didn't. This is not one of those 10 postulates. But we did talk about parallel lines only a few times before. But when we have parallel lines, then you have to start thinking, hey, I have alternate exterior, alternate interior. I have consecutive angles. I have corresponding angles. I have a lot of different ideas that I could use here. You guys got to put together the right combination. Remember, in the given, it's telling us parallel. That's what those slanted lines are, right? And it's hard to see on here, but I tried to add little arrowed lines. They're little arrows that would signify parallel. So, number 1, angle Q, that's a bad Q, is congruent to angle S, and PQ is parallel to SR. Reason? Given. So I'm going to go up here and I'm going to place it on there. Parallel, I can't do anything yet. I'm going to have to use that parallelness to figure something out along the way. Does anybody else have a good idea? The one that we use quite often. As the video rolls. Reflexive. So someone other than Ella is going to tell us what's using the reflexive property. Reflexive property, what is it? Hayden.
Is it PR congruent to PR?
PR is congruent to PR. Yes, line segment PR is congruent to line segment PR. Their definition, or the reflexive property, is the reason why. So now I go up here and I'll put 2 tick marks on that. Awesome. What else can I say? Can I use the fact that I'm given that they're parallel for something? Will. Alternate interior angles is the definition, or the reason, huh?
Yeah.
Alternate interior angles. Well, what is that going to help me with? What are you trying to state? PRS is congruent to
Angle RPQ, is that right?
RPQ. Is it correct? He's saying, where are we at here? PRS, which is this angle, is congruent to RPQ, which is that angle. Is that true? Because of alternate interior angles? Yes. So, are we done? Do we have enough information to be done?
Sure.
Can we actually now state the show?
Yes.
So in 4, triangle PQR is congruent to triangle RSP. Reason. It's angle, angle, side. Now I said earlier that I was going to talk about that situation. Why don't I want to use angle, 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 side? Do I have all of the angles? Not right now. Could I add an extra step in there and actually find and state it? That angle QRP is congruent to RPS? I could. 2 angles implies all 3 angles. Or also by alternate interior angles, right?
Correct.
So I did not go the extra step, so I can't use something I don't have. You don't have all 3 angles listed, therefore you don't say it's angle, angle, angle side. Does that make sense?
Yeah.
And you are done, because that's what we were required to show. And the last one looks scary. It's not as scary as it seems. Guys, is there any letter in the middle?
No.
No. So guess what? You're probably not stopping in the middle. That means either I'm going to try to show that the top triangle is congruent to the bottom triangle, or I'm going to show that the left triangle is congruent to the right triangle. So put your given in there, and you guys should hopefully see which ones you're trying to make the link. So we have the given stuff out first. We have this idea that we have some things that are congruent. I'll state that right away. So yx and xw. That's nice. But then it also states that zx is bisecting yxw. So I can't do anything with that yet until I state something. So maybe let's state that first. What is happening? What am I doing with that? What am I doing with this piece of information? Okay. So what should we state? Definition, angle, bisector. What would be the reason or statement, if that's the reason?
Would be angle YXZ is WXZ.
Is that right? Which means this angle and that angle are the same? Now, wait a minute. If I'm looking at this, it seems like I've got pieces for this side and this side, right? So we're probably doing a left-right triangles. So does that left and right triangle share anything? Yeah?
The right triangles because of perpendicular lines.
can we guarantee that they're perpendicular, as in they're crossing right here, at perpendicular angles? It looks like it, but are they telling us? No, we would have to deduce that through our steps. Can't state that unless you can back it up. Other than, it looks like it. Not good enough. What are they sharing, guys?
X blank, X something.
X, Z. XZ is congruent to XZ because, reason?
Reflexive property.
Reflexive property. Reflexive property again, which means those are the same, the longer lines through the whole thing, right? Okay.
Y, W, W, Y.
Do we have enough information to state they're congruent on a whole? The whole triangles?
No,
Yes.
yeah. Side angles are.
Triangle YXZ is congruent to triangle WXZ. And what's the reason? Side, angle, side. Guys, we have a side, an angle, and then a side that's shared. We're not done because now we can state our last statement. YZ is congruent to WZ. And our reason for this? C, P, C, T, C. And you are done. Homework, lesson 15, page 119, 3, 4, 5, 6, 7, or 3 through 7. Have a great day.